This podcast is not meant to be professional advice of any kind. It is meant to be informative and entertaining. If you make any changes to your life, see the appropriate professional before you do so. Hello and welcome to Super Age. My name is David Harry Stewart. I'm the founder of Ageist. At Super Age, we help you live better and become the best version of yourself. And who doesn't want a super age? Today's show is brought to you by Inside Tracker. Go to insidetracker.com/age to save 20% on all their products. Get yourself a dashboard to your inner health. And we'd like to welcome to the Super Age podcast a new sponsor, Element, spelled LMNT, my favorite electrolyte mix. That's what I put in my water at the gym. That's what I put in my water in the morning. Go to drinkelement.com/ageist and check out the special deals they have for the listeners of the Super Age podcast. Welcome, everyone, to episode 95 of the Super Age podcast. This will be dropping on August the 3rd, 2022. So how's everybody doing out there? We've had, it's just been like a heck of a week. I was in Los Angeles last week meeting clients, meeting some new people, meeting old people from my photo past, which was really kind of great. And then back here, oh my gosh, we're launching the Ageist Book Club this week. So check that out. That'll be info about that in the newsletter this week. And we're also going to start working with Leap, the social media company that we've been mentioning recently, which is really all about human connection. And we're all about that. And we're going to have some ageist discussions on Leap. And that's coming up soon. And then we've been making these videos and we've been putting them out on, the other social media channels, including TikTok, believe it or not. We actually have like a reasonable following on TikTok now. I don't know. TikTok's crazy, but it's, wherever people are, that's where we're going to go. And we made really this really fun video last week that we put on Instagram that we did for our sponsor, Inside Tracker. And it's all about, if you want to know what I do at the gym and why, I sleep a lot and I'm tired a lot, check out that video. It's from a couple days ago. The front slide on that is like me on a treadmill. So, that's what I do every morning. This week on the show, we have someone fascinating, to me anyway, and I think it's going to be fascinating to you too. Dr. David Hardy, who deals with functional neurology, which is something I hadn't even heard those two words put together before. And he does some pretty amazing things. So we're going to get with him in just a moment after a quick word from our sponsors. Today's show is brought to you by Inside Tracker. Inside Tracker is the dashboard to your inner health. Just as a car has a dashboard so you can tell how fast you're going and how much gas you have, you need a dashboard for your inner health. You need to know what's going on inside your body if you're going to optimize it. You need some way to monitor what's going on inside your body. And then once you know what's going on inside your body, you need some way to help optimize that. And this is what I get from Inside Tracker. With their 43 biomarkers that they're testing, along with the genetics that they test me for, I know what I should be eating to really optimize where I want to be. And I get to choose that target of where I want to be. Am I working on brain health? Am I working on longevity? Is there something with my fitness that I'm interested in optimizing? The app will make recommendations personalized to me based on my blood work and my genetics. And that's something that I just think is invaluable. It's not a replacement for seeing my doctor. It's not a replacement for any of the other professionals in my life. It is an additive, but it is an additive that is with me every day, all day. And I can consult it and I can see what should I be doing right now. And then I can test again and see what changes have happened. If you go to insidetracker.com/ageist, you'll save 20% on all their products. Today's show is also brought to you by Element, the electrolyte mix that I've been using to stay hydrated and to keep my electrolytes in balance. I started placing Element electrolyte mix into my water after my workouts on the recommendation of a friend of mine who's a 50-time Ironman competitor. I told him that I was having a lot of trouble recovering from my workouts, and I thought it was my age. And it turned out it was my electrolytes. And once I started putting Element into my water, I noticed an incredible difference in my ability to recover from my workouts. It went from, truthfully, an hour or two to like 10 minutes. Because the problem was my electrolytes were off. Now what I do is I put Element in my water when I get up first thing in the morning. I also have it in my water that I drink during the day. And then, of course, at the gym, I make sure that there's Element in my water. And of course, in my beloved sauna, the same thing, Element in the water. So it turns out that some of that brain fog and just muscle ache and sluggishness that I was feeling was not age-related. It was actually electrolyte-related. We talk a lot about hydration on this podcast, but the electrolyte mix within that water is really critical. Right now, Element is offering listeners of this podcast a free sample pack with any purchase. That's 8 single-serving packets free with any Element order. It's a great way to try out all 8 flavors and share Element with a salty friend. Get yours at drinkelement.com/ages. This deal is only available through this link. You must go to drinklmnt.com/ageist. We'll be leaving that link in the show notes too. After you check it out, let me know what you think about it. Did it make the change for you that it did for me? Hey, David, how are you today?
Oh, I'm doing fantastic. Yes. Yeah. Great to be here.
I am so excited to have you on. We had a conversation last weekend, and I just thought, oh, people need to know about this. So you deal with functional neurology.
Yes.
Did I get that right?
Absolutely.
Okay. So first off, what's that?
Yeah, exactly. Functional neurology is to isolate the parts of the brain that are overactive so you can calm them down, or what parts of the brain are sluggish so you can figure out an exercise stimulation modality to make an improvement in that part of the brain. And it is absolutely amazing the results you get when you're specific with these different pathways in the brain and nervous system, and how you can just improve function. So kind of the 3 top groups, if I would say that I've worked with in my practices, have been brain injuries, concussions, cognitive decline, neurodegenerative disorders, and then kind of that ADHD, impulsivity, and post-addiction realm. And so looking at physical ways to rewire the brain nervous system to improve all these different conditions. And then now I'm trying to see how I can apply all this information into peak performers and entrepreneurs, business people, and kind of the leaders out there that want to make a change to the world as well, that are obviously bombarded by stress and other factors that are gonna take its toll on how you perform.
Can you make me smarter?
Absolutely. That's the exciting thing is we've done cognitive tests pre and post with these therapies. And you see areas of these cognitive tests improve. And the cool thing is it's individualized. So it's really, okay, here's what we find. Let's do some training and see what the results are. So you don't have to wait around for these huge studies that take years, if not decades, to complete. It's basically, okay, well, here's pre and post, and let's see the difference in where we can take your brain.
Okay. Now you have my full attention. Since you haven't done a test on me, let's make up patient X.
Yes.
And so he comes in, and what is this test? What are you doing to him?
Right. It depends on the clinic I've been, but the basic part of it is going to be the neurologic examination. Now, there's textbooks on the neurologic examination, and traditionally it's kind of been used to weed out pathologies or kind of what parts of the brain have maybe had a stroke or something in that realm. But what's been really amazing with these examinations is you can start to isolate pathways in different parts of the brain. And then you can kind of go, okay, well, this pathway is weaker than this other one. And then, of course, match it up with something that's going to make an improvement to it. And That's the key. And now we can also use a whole bunch of diagnostic equipment, and we can read brain waves. Some people are going to do big, expensive scans as well on the brain. But basically, when it comes to the nervous system and how it functions and how you can assess it, is by looking at these different reflexes, these muscle movements, and really go from there, and just build it up, and that's also going to lead how you're going to train that system and make those improvements.
So I don't think I have any brain pathology. My wife will disagree with that, but let's assume I'm
right,
reasonably okay. And I come in and
absolutely.
I say, Dr. David, I want to be smarter. I want to be able to like handle more complex things quickly. What kind of tests are you going to do on me?
Right. The exact same tests. So basically, everybody's got parts of their brain, once again, that are overactive and that we can calm down. And then other parts of our brain that are sluggish or weaker. So if I use the muscle analogy, if we did a muscle kind of assessment on somebody who's had an injury, we'd isolate what part of that muscle is damaged and then how to strengthen it. And there's several different muscles that can be damaged in one sort of injury, right? But if we were also to look at a peak performer who wants to improve their power in their muscle, we'd look at those muscle asymmetries and imbalances, and then we'd come up with an exercise plan to make that change. Well, the brain's no different. We've got all these kind of weak or strong areas of our brain that we can hone in on and make those changes, make those improvements, and improve our lives, our performance, and how smart we are too.
So I come in, you do tests on me. What I need an example here. Like,
yes.
Because you've treated a lot of people. So some like reasonably well-performing person, no obvious pathologies. They come in, they say, I want to be smarter. What would you possibly see there, and how would you go about improving this, and how long is it going to take?
Perfect. Let's start at the bottom part of the brain. So let's go brainstem, cerebellum, which is over 60% of the brain and most of our habit forming functions anyways. So the first thing we're going to look at is going to be autonomics, heart rate, blood pressure, respiration, pupil size, because this is these quick, fast systems then that obviously fire all this stuff that keeps us going. And these structures are going to be more kind of midline in the brain and then branch out. So we shine the light into a pupil. Well, before we look at the pupils, and some people are going to have a pupil that's larger than the other side. Right there, just observing that, we know there's something going on in that autonomic system. Some people will have blood pressure that's different from one side to the other. And once again, we know that how the brain and nervous system is regulating our blood pressure is skewed. It's not working properly. And we're going to go through that. And we might stress people out a little bit to see how that system responds. So we're always looking at heart rate. And for athletics, you've probably heard of heart rate variability and measuring your heart rate when you're doing all these tasks. It is that fast part of the nervous system that regulates what we need for oxygen and where we send all this blood and shunt it around the place. We're going to look at the postural system, balance, orientation, muscle tone. We're going to look at reflexes, sensations. Let's probably for coordination too, when we get into like the cerebellum, everybody's seeing episodes of those roadside DUI tests, right? Yeah. Well, coordination and balance, basically those primitive structures, alcohol really nails that part of the brain and causes it issues. Well, same with toxic stress and lifestyle and all these other things, is that coordination system can be, once again, kind of thrown off, or there can be imbalances from one side of the brain to the other. So we're going to do these coordination tests because that cerebellum, which has roughly about 60% of the neurons in the brain, then fires into our frontal lobes. There's a huge connection between the cerebellum, learning, and frontal and cognition. It's the center for coordination of both movements and thoughts. So when you see somebody who's got kind of these jerky or tremors, you know that part of the brain's not working well. And then you could go into your cognitive tests and you're probably going to see slowness or jerky thoughts or scattered thoughts. And then you kind of combine the two, and then you're going to go through and see, okay, well, let's test it. And then let's see if we can make an improvement to it so that we're just not stuck in waiting for it to decline farther and get to the state where it is pathological.
I need to ask you about it. So now you've got me going here. So what you're saying, if I understand this, if there's something in my autonomic system, something simple is like left pupil different than right pupil.
Yes.
That is an indication that there's some sort of that gets reflected in my cognitive part of my brain. Is that
absolutely that regulation
really
is not working well? And yeah, it can be a
so
problem.
Whack.
Yeah.
Okay. So I love that. Like the tests that you're doing, then they're not necessarily cognitive recall reasoning tests. What you're doing is you're doing physiological tests on my body.
Exactly. As kind of that baseline part of it. Another way to look at it is all these primitive structures and primitive functions of the brain are the foundation for a good, healthy brain. So you want to go into a house that you're building and start looking at the curtains or the baseboards before you go into the basement and see if the foundation is leaky or not working. And that's what we're doing a lot with cognition is we're putting things that should be more advanced functions ahead of everything else. And the thing too with cognition, especially as we age, is we've become really good at sort of one aspect. So yeah, we can appear smart because we've always rehearsed basically what we read or everything else. But the rest of the ship's starting to, once again, leak and let things through. And eventually it's going to lead to decline in our cognitive thoughts as well. And we start to see this. Our sensory processing starts to dull, our sensations start to dull, our movements start to dull. And then learning new tasks can't take place. And then even the ones that we start to be really good at, we start to forget things. And that starts to dull as well. And the whole reason we have a nervous system, and there's a great TED talk on this, is this. Yeah, if you have a chance, look at this TED talk. The guy goes through and basically he does a great story about the sea squirts. The sea squirt's this larvae, and it's got a little brain, a little nervous system, and it swims around. And then when it finds the perfect rock, it plants itself and digests its nervous system. So if we're not moving, there's no point in having a nervous system or a brain. And this goes from the lowest larvae insect all the way up through all these different animals until we get to our brains, which are so well advanced that we become so in tune with our cognitive abilities that we forget why we actually have a nervous system. Our nervous system is there to regulate our own body against the outside world and to move around and read and react.
So what then is the relationship between moving and thinking?
Yeah, if we're not all of our tasks and how we've developed is to, once again, taking all this information from around us, apply it to where we are, and then move and react to something. Go get food, go do this, all these tasks. And it takes in a whole lot of sensory information before we're able to make these decisions. And that's the beauty of the brain, is basically it's this vessel of information coming in through our receptors that fire through a nerve, go up the spinal cord and into the brain where it's processed. And then we have an autonomic reaction to that. Then we have an emotional reaction to that. They're called feelings, the root word being feel. And then we have a cognitive response to it. So we always feel before we think. And then we fire down and we think, and it changes that loop as well. But everything is coming in from receptors from that outside world, our senses, and from our inside world, our interoception. And that fires into, again, how we feel, and then how we think, and then how we react. And that's the basic steps and systems of the brain. And then it's this really evolved past that. But all our thoughts is basically evolutionarily gravy compared to the rest of the brain, which is to move around and react. And the cool thing now is, like, in the leadership world, you start to see these books on like habits. Well, habits, they can only be performed by doing. And then we naturally start to build that. And a cool example out there is cortical blindness. So nothing's being done to the actual eye or to the nerves going back into parts of the brain. It's basically in our cognitive centers where we realize vision. So that part of the brain has been wiped out. But the primitive centers are still processing that information from vision. And if you ask these people, they can't see anything. But they can still maneuver around a room. They can walk, and you can put a chair or something in front of them and they'll sidestep it and continue to walk. But they'll have no cognitive awareness that they actually did that. So the majority of our brain is functioning on autopilot, and we're not even aware of it.
So let's go back to the pupil.
Yes.
So you see me, you look at my pupils, one's out of, reacting differently to the other. Therefore, something's off in my, brainstem somewhere. Something's not quite right, which means that the house is unstable. So I'm not thinking as well as I could. What are the sort of modalities you use with people to improve such things?
Yeah, definitely. So we're going to look at the nerves that go into these parts of the brain. So we look at cranial nerves a lot for kind of these midbrain or pons or brainstem areas. And like, if the popular one out there right now is vagal nerve stimulation. So you're finding a way to fire into these nerves that then once again hit the brainstem and then stimulate that part of the brain.
Tell people what's the vagal nerve.
The vagal nerve is responsible basically for digestion and a lot of kind of those primitive functions. And it's going to be low in the brainstem. And it's going to be those autonomic functions and things that we can't really control, but we need them to react fast to control our autonomic nervous system. And then we can go higher up in the brain and we can look at other cranial nerves that come into it. And like, we all want to be in this relaxed state when we need to be, right? Well, let's look at hypnosis. Why does it give us that state of just zoning out? Well, horizontal eye movements are going to fire into that pons area. Different sounds are going to kind of stimulate that pons area and soothe us. That's going to be more your serotonergic system. And then we can move up and we can look at the cranial nerves that then are higher up in the brainstem into our midbrain. And well, we look at vertical eye movements because those are the nerves that come out of that part of the brain. And that's going to be more our dopaminergic system, that excitement side of things. And we can reprogram the brain by using the right frequency, how often we do these exercises, and intensity and duration, and make the brain learn things other than just talking to it. We can do repetitive stimulation through these nerves, through our senses, and make changes to the dopaminergic system, the serotonergic system, and to memory, coordination, all of this.
So if I understand this, if you get my pupils to react the same way, so that's in balance.
Yes.
By not by doing, some sort of movement. So we're causing me to see something. I'm the input. You're doing some sort of input to me.
Yes.
And that once my brain sort of clicks onto that, immediately my frontal cortex, the part that my cognition, the part that I think with, I'm smarter. Is that right?
Could potentially become smarter. Absolutely. And the reason we know this is by doing all these cognitive tests in conjunction with it. So yeah, we can go online and we can do these cognitive tests, and then there's more clinical ones that we use, and we've seen the cognitive scores improve without doing a signal cognitive task by just simply stimulating these lower parts of the brain. It really is kind of
this is amazing to me.
Yeah.
So, well, let's say I do have an issue. Say, let's say I have early onset Parkinson's.
Okay.
So tell me, like, what is Parkinson's, and then how would you help? It's an ongoing degenerative disease, right? So
Yes.
You can't really stop that, but you can probably. What would you do?
Yeah. The same thing, isolate the parts of the brain. So in Parkinson's, we know that it's going to be more into that midbrain dopaminergic system. And then we look at the wires that are coming into that part of the brain that would actually stimulate that part of the brain, and do exercises based off that. And the thing is, especially with these neurodegenerative disorders, is that part of the brain's more fragile. That's why it's declining. So really it becomes this skill of trying to get the right amount of stimulation without overstimulating that part of the brain. So really with these exercises, and the key takeaway is that we do them with repetition more so than with intensity. And we start to see these changes. But if you don't do it enough and at the wrong intensity, you're not going to make a change to it. And it becomes this puzzle, this art form to really make that change in that brain. But the saying, neurons that fire together, wire together, go for all parts of the brain, not just doing a math problem or reading. And that becomes exciting for people that are having these disorders where they're starting to decline. And that stimulation model can really start to work and fire up these parts of the brain. And well, we go into the wiring part of it quite commonly in the stimulation, but we have to realize too that this should be healthy living tissues. So you still have to look at the metabolic side as well, and everything that's going on there, and give it the right fuel. And well, the brain basically processes fuel-wise oxygen, glucose, and ketone bodies. And it's reliant on the body to get it to it. So that's why the autonomic system is kind of that baseline point too, is that we want blood to be shunted into the right parts of the brain, and we want that autonomic system to be firing appropriately, and so that it supports other parts of the brain and is healthy as well. But we also have to look at all these nutrients that come in, and we have to decrease the inflammation, and we have to look at immune function and everything else as well. But the cool thing about the stimulation model is, yeah, you fire into these cells, these neurons in the brain, you activate them Well, when you activate a neuron, basically what happens is it sends a little signal from one of the receptors saying, I got activated, which sends a secondary messenger into the nucleus of that cell. That nucleus then has genetic expression because of these messengers being sent to it. Then it produces the RNA and then the proteins, and then it starts to make that neuron healthier. So by activating these neurons at the appropriate rate, you start to stabilize them. And that becomes very exciting for these disorders where people are declining, and it becomes exciting for kind of that longevity and just being able to perform better for longer as well.
I'm thinking about, you use this term wiring a lot.
Yes.
Electrical system. What I've noticed when I work with an electrical system is that if I get the switch right, it changes immediately, unlike going to the gym, which may take 6 months.
Yeah. The thing about neurons is they're very metabolically active. They're constantly firing at a certain rate, oscillations, and we measure these. They're called brain waves, and there's different brain waves, different frequencies of it, but that's happening in milliseconds. And that's constantly being turned over and new cells are being produced. But the cool thing about a neuron versus a muscle is that these proteins, through that stimulation model we just explained, happens in milliseconds. So you can change that protein expression very quickly with neurons. Whereas with a muscle, it's going to take longer to regenerate that protein. It's a different response. It's less metabolically active versus a neuron. And it's cool because you can see it in real time. You can do these stimulations and see if it makes a response to that pupil or whatever other finding you have. And when you see that change, you get really excited because now you know it's just a matter of that repetition, practicing it, and changing the intensity of the exercises as you go along.
So one of the things I've noticed, a lot of us sit.
Yes.
I'm actually, as we're doing this now, I've tried to stop sitting. I stand now. But sitting causes our glute muscles to just go into a coma. They're like, you don't need me anymore.
Yeah.
And what I've noticed is that sometimes when I go to the gym, I do these sort of like warm up sort of exercises, and some of it is just to tell like Mr. Glute, time to work.
Yeah.
What's happening? Because what is that about? These warm up things I do, these like small movements of my leg around my glute. It's not hard on my glute. I'm not panting, but what's happening there that tells? Because that's a brain thing. It's not a muscle thing, right?
Yeah, exactly. Your brain and nervous system are constantly firing down to muscles to activate them. So if you don't use it, you lose it. And that goes especially for neurons and different pathways. If you become sedentary and inactive, these pathways start to deteriorate and decline. And yes, sitting is going to cause certain muscles to be turned on and off more so than regular. And then by doing these little activation exercises, you're reconnecting that pathway to get, I need to fire down and get this muscle to wake up and to work. Now, the other thing we can use with muscles is if you think about a muscle, it's always on, off, on, off. And it's at a rate where we don't notice that too much. When we do know, it's kind of like those fluorescent lights. It's flickering at a certain rate, but we don't notice it. But when we start to see tremors or these movement disorders, then what we know is that frequency of firing is off. So that's another warning sign that the brain our nervous system is starting to deteriorate in certain aspects.
So with age, there's a lot of talk about, well, your your fast twitch muscles don't work as well. And what I'm starting to think by hearing what you're saying here is that with time, sort of our nervous system becomes lazy or inaccurate.
Yeah.
The wrong things are firing at the wrong time. Is that right? And what can we do about that?
It's exactly right. And we start to notice this in decline. And we can see this with people. Like you look at facial expressions, which are different tone of muscles. You look at how people walk, and instinctively you say, oh, that person's a little slow, or that person's anxious and heart going off. And we pick up on these naturally. But if we look into it and study it a little bit more, then yeah, we start to notice different aspects of the motor system declining at different speeds and different rates. And well, let's use another example. So we know stress is toxic to us. So right now, picture yourself being stressed out and tired and sluggish. And then think about how you would probably be sitting, standing. You'd be slouched over, hunched, and more in this kind of flexor posture. And then think about when you're excited and you're confident and you're rocking things out. What's your posture like? It's upright and it's solid. So different postures is actually telling us about how our brain's firing and working in that moment in time. Now, the other thing is if we go from development through basically midlife into degeneration, your cradle to grave aspect of it. When we come into the world, we're in this fetal position, we're tucked in. Then as we start to develop, we become upright, more extensor tone, that confidence pose. And as we perform, we're in that confident, upright pose. And then when we're stressed out, we go into that hunched over pose, posturing. And then as we decline, we start to go back into that posturing pose where we're flexor dominant and we're hunched over, hunched backed. And then we're losing our balance and our other functions at different rates. And then we start to see it. So that posturing is actually a reflection of brain health as well.
But can it go the other way? So
absolutely.
If I want to if I fix my posture, do I fix my thinking?
It would be kind of looking at your posture throughout a longer period of time. But yes, basically that posturing, that flexor dominant posturing. Let's look at another example, stroke. So we know in stroke that a part of the brain's being damaged. And then we see this spastic posturing, that flexor dominant tone, kind of that wrist being flexed in. You can't extend and open your hand because that inhibition of that flexor tone is being taken away. So our frontal lobes fire down through the pontomedullary reticular formation, if you want to know that. And it inhibits autonomics, heart rate, blood pressure, respiration, and emotionality and flexor tone. That's those inhibition circuits, which is cool because then you can start to see it.
But I guess where I'm going with this is, like you said, like if I feel stressed, I sort of collapse forward and in.
Yes.
But then if I catch myself doing that and I say, no, stand up, shoulders back, head up.
You just said it. You caught yourself. So when you catch yourself, are you at more of an aroused state?
I probably catch myself in the mirror and it's like, oh, okay.
Yeah,
and then I fix my posture.
Snap out of it.
But what happens is, at least with me, I feel less stress because I have changed my body position.
Exactly. Yes.
It's two-way. Okay.
Exactly. You're sending better signals up to the brain as well. So just being more upright, you're going to send better signals that, okay, yes, here I am, brain, and I'm doing better. And there's less stress to some of these muscles So if you're in that stress posture, what's your head and neck like? It's forward. And then you have
Right.
all this tension in through that muscles.
Right.
All that's sending signals up to the brain as well. And then that signal fires into our feeling centers, and we're annoyed and sore, stiff, and we're probably going to snap at people a lot easier.
So, what about, are there other places, are there other techniques like this idea of, I'm just fascinated with this idea of the sort of feedback between the physiological and the brain. So things like we just discussed, like the posture, but you know, tickling someone or intermuscular stimulation or other sort of novel things that become that input to the brain,
Yes.
right? And the brain's like, oh, this is a new thing. Um, is, talk to me about that. Does that work?
Absolutely. All of this is stimulation into the brain. We're firing receptors going through nerves up into the brain where it stimulates how our brain is working and functioning. And different stimulations are going to have different effects in different parts of our brain. And it really is, life is a sensory experience. And all of this fires in and makes our brains better or worse, depending how we target it. And this is why there's always been kind of these more abstract things around, I hate calling it, but alternative health modalities, is that all of them stimulate a receptor. So you look at chiropractic, we're stimulating those big receptors of joint mechanics and muscles that fire up into the brain. Aromatherapy, you're stimulating the olfactory nerve. Light therapies, you're stimulating that cranial nerve for light that fires back into the brain. Sound therapies, you're stimulating that sound nerve that goes into the brain and stimulates the brain, and it changes our state, it changes our mood, and it can change it for better or for worse depending on on the stimulation.
Input, process, output. Change the input,
Exactly.
different process, different output.
So here's a question for just to kind of stimulate that response there. So we know multiple senses go up into the brain, then multiple connections. So when that information actually gets processed and leaves the brain, so the nerves going out down through the spinal cord and out into the body, there's only basically two areas that nerves go out into the body. And let's guess what those are. Where do the nerves coming out of the brain actually go?
Muscles.
Ding. Absolutely. And the second one?
I don't know.
Going to be glands.
Oh, right.
So those are the only two. And then we can start to kind of subcategorize it from there. So those nerves are going to fire into either autonomic muscles, like our gut, or those muscles that shunt blood, or change pupil sizes, or it's going to fire into skeletal muscle that we move. And then, of course, glands, it's going to fire into all these glands. And that's why we look at the hypoadrenal pituitary axis or those things, is that, yeah, there's a response and the brain processes that information and says, oh, I think I need to change some of my hormones here. Or I've been running, it's hot outside, I need to sweat more. And all of that is a function of the nervous system. So muscles are easier to look at than glands, though, because glands, of course, they can have issues themselves as well. But yeah, and looking at the brain and the responses to all these other systems starts to explain some of these more kind of anecdotal results that alternative therapies have gotten before, is that you're changing that processing and output, which is not only going to fire down into the body, but it's going to fire into other systems, such as our hormones and everything else as well.
But there has to be a strategy, right? So,
Yes.
you know, it's one of the things that I find I have some difficulty with alternative medicine when it does not have a strategy, a cause and effect.
Mhm.
You know,
Right.
And that's what you're describing to me is functional neurology is a strategy.
It's
You
a
do X,
system.
Y
Yeah,
happens.
exactly. It's to isolate these better,
Right.
because all of these therapies basically have been discovered or honed by practitioners doing it and seeing results. And that's why some of these ancient therapies are making comebacks, is because, yeah, they've been around for thousands of years. People have started to notice changes with it, and now they've got kind of procedures for it. But the cool thing now with all the technology and how science has developed is you can get a lot more accurate with these things.
Exactly.
Yes.
That's a better, not strategy is the wrong word. Accuracy.
Yes.
I'm going to back to my personal situation, which is my favorite one.
Mhm.
So I ski, and one of the important parts of skiing is proprioception. Like,
Yeah.
where am I? I'm now in this. I'm highly dynamic, and an error on my part about proprioception can lead to me and a tree and a hospital.
Yes.
So I want I want to avoid that. But what I've noticed is with time, my athleticism hasn't declined all that much. My aerobic capacity is down, but there's basically
Mhm.
but basically everything's working fairly well. But my proprioception is not as good as it used to be.
Right.
Well, and that's a brain thing. Um,
Absolutely, it is. Yes. Yeah,
so
it's a
what do I
nervous system
do?
thing. It's about getting that accuracy back. And
Yeah.
I love the ski example because this really tells us what our brain and nervous system is doing and designed to do. So the brain has a frequency of firing brain waves, right?
Yeah.
And of course, yeah, it's that sensing the outside world, sensing your own body, and processing that information. Well, this timing is at very quick milliseconds. And a skier is a good example, is that you need to know your body position and that turn coming up, and you need to react to any bumps in the snow. And you need to put all that weight and everything and feel it into that small slice of the edge of your ski and at the right pressure to make that turn. And if you don't calculate it right, then yeah, you'll blow out that turn or you'll need to compensate for it if you don't wipe out. And it becomes seconds off your time. And that's an elite athlete. So with an elite athlete trying to build that nervous system up, yeah, you're looking at these minuscule little changes in that system. And then people with pathology, sometimes it's easier to kind of diagnose the nervous system because it's more apparent what's not functioning properly. But yeah, if we're noticing a change in these systems, then we need to look, okay, well, is your brain starting to think your center of gravity is in kind of a different spot? So yeah, we need to look at that. Is muscle tone kind of changed from all these injuries we accumulate over periods of time? And we need to look at that aspect too, because that's abnormal signaling that's happened and the brain is trying to compensate for that. And it's adaptable. It's always making these changes and different calculations to how it's reading our body and then how it's reading the outside world. So where is that disconnect or going on with the integration of all these systems that can keep us on this skinny little sharp ski
Well,
and I'm sure you're doing like double blacks and going going completely.
well, so I mean, is my pathology is aging, and
Mhm.
is
Yeah.
aging really just an accumulation of my brain's adaptation to all these minuscule injuries I've had over the decades?
That's definitely one part of the puzzle. And then, of course, it's cell health as well.
Mm,
So, yeah,
right. So, like my mitochondria are probably not as
hmm
zappy as they used to be.
exactly. Yeah. And the immune system, too, like, and this is going to be one of these hot topics that continue to go on with everything going on in the media right now in the past few years, is the brain is the well, pretty much the most heavy immune regulated system. So our immune system is supposed to turn over cells and recycle our cells. That's a function of the immune system as well. So, of course, neurons we mentioned are very metabolically active. They turn over very quickly. So it makes sense that there needs to be a lot of immune cells to take care of this as these cells basically wear out and to clear that all these products and abnormal proteins out of it. And the immune system has other functions, though. Not only is it turning over cells, there's different parts of the immune system and different cells of the immune system and different signaling and messaging of the immune system that gets skewed as we age as well. And it gets skewed because of diet, toxins, and stress. And then, of course, pathogens, viruses, bacteria, and everything we're exposed to. So there's can be polarization of the immune system where basically it gets skewed into more one function versus the other. And that too can start to wear on the brain and start to change how the immune system clears out all the junk that we accumulate throughout a lifetime. And that's going to change how the brain and nervous system works as well. So it really is this a better approach to say about the nervous system, the immune system, and the endocrine system is that they're all communication systems within the human body that are interlinked. And then it doesn't become just one department and one referral. It becomes that interplay of all three of them together.
So if I want to increase, so taking the community, if I take the communication system idea,
Mm-hmm.
um, perhaps my vocabulary has become reduced with
Yes.
time,
Mm-hmm.
and I want to add to my communication vocabulary. Does then doing things like this novel stimulation, and I'm thinking novel movement of
Mm-hmm.
some kind, which is actually really, really difficult, like doing
Yeah.
something, like if I just said to you right now, the fourth toe on your foot, bring it up, like, I mean, we have the, we have muscles to do that, but probably
Yeah.
quite difficult. So like a novel, doing actual novel movement with which would increase the vocabulary, the range of like different things that my brain can do. Do things like that impact these other systems?
Yes. And all of it's interconnected. If you fire one part of the brain, you're going to fire another
Yeah.
part of the brain and so on and so on. And we know this. And then too, you can start to layer exercises together. So what we call it dual tasking. So it's kind of like, okay, think and chew gum at the same time. So we're doing kind of a movement activity now with cognitive thoughts and things as well to layer the therapies and modalities to get people sharper. So, and as you mentioned, which is a huge takeaway for anyone listening, is anything novel is going to stimulate the brain. Anything new is going to stimulate the brain in a lot more impactful way. So this is also a way to measure decline as we age, is how able are we to actually learn new tasks? And if we start to see that happen, then we also know that then the integration, the processing isn't as sharp, it's not as quick, and it's not as accurate.
I've actually there's an exercise program that I recently heard about. I think called Vivo or Vivio, where they do exactly that. It's movement with cognitive activities.
Yes.
the two at once.
Mhm. So we do this in neurologic testing as well. Is we'll dual task. We'll have somebody walk, and we'll get them to do a cognitive task. Hey, count backwards from 54 by sevens. And if they start to
That sounds
freeze,
really hard.
yeah.
I would fail.
Mhm. Well, we're looking for fail.
Oh, okay.
Because, yeah, if we start to see these systems fail, then that's our baseline. It fails doing this. Okay. Well, can we do something that improves it?
Right.
And that becomes the big question with all these rehabs, is to actually have something that you can kind of go on baseline and see if it improves. And you see these in concussion tests and yeah, your roadside DUI tests and everything else. And yeah, well, let's apply it to basically everything else, that performance and how we want to live and how sharp we want to be when things start to maybe be in more of our twilight years.
So I want to do like the reverse DUI.
Yes.
So I'll go back to my favorite sport, skiing. And I've just come down something like steep and I'm going badass fast. And I get to the bottom and I feel awesome. Like my brain is fully lit up.
Yes.
What just
Isn't
happened
that a
there?
great sensation?
Oh, it's unbelievable.
Great feeling?
You could ask me the most complicated question you could imagine. I could just like knock it off. Yeah, here it is. Boom, answer. Because I'm just so lit up. What happens there that, you know, the movement stuff lights up all this other? Help me out.
It's this massive bombardment of sensory stimulation that gets the brain to wake up and be at a higher frequency of firing. And yeah, it's multiple areas of the brain communicating back and forth at milliseconds and reacting to the world around it. And oh my God, if it does that correctly, wow, do we feel good? And then we want more of it. And that's a good thing.
This is why I can't watch television. I just like, I will, especially like, I like nature TV. That's kind of fun. But
yeah,
I
prefer nature though, right?
Nature TV is really fun. So like, you know, I want to watch Bear Cam, like awesome, cool. But most like television is sort of designed for this like narcotic effect. Mm-hmm. And I find that if I watch it for like a few minutes, it's the reverse thing. Like it's like everything just sort of like shuts down and I can't think and I can just feel my cognition dropping.
And basically, if we overstimulate one sense more than the others, then we're going to see decline in the senses we're not using, or basically we zap out this system that we're overstimulating. And right now, so many of us are way too visual dominant. And we see this in aging as well, is somebody standing there, they're able to walk fine, but you take vision away and they fall.
Right. That's the test. Stand on one leg. Okay, great. Now close your eyes.
Exactly.
So why is that? That's proprioception. Why is that? How do you fix that fail?
We need to get the sensation of proprioception, that body awareness, that movement of muscles and joints firing back up into the brain so that those neurons start to become healthier in that part of the brain. Because when we're visual dominant, our posture usually changes to our center of gravity, and we're reliant on one sense versus the others. And if we take that one dominant sense that's still working and we take it away, then the other sense isn't there to do its job. And that's an unhealthy brain. And that's a huge risk category, because later in life, falling is dangerous. If a lot of elderly, if they break their hip or something else, they're not likely to come back and be functional again. And there's risk factors for eventual death with that as well. And well, let's back that up. That is an extreme case. Well, not so extreme because it's out there and it happens constantly. But let's back it up a few years or a decade, and we start to notice that we're not performing as well in this.
Yeah.
that's an indication of probably eventual decline. And we don't know the pace of that, but you can start to be doing these things to monitor your own health and this aspect of the nervous system and brain, and chart where you're at. And not just that, if you're starting to notice it, you can chart improvement instead of just waiting for decline and pathology to take place.
Absolutely.
And I think that's the most empowering thing about exercises, stimulations, and everything we're preaching with brain health, fitness, and wellness.
All right. So I'm going to ask you to give me something practical. So I'm actually, as we're doing this interview, I'm standing, and when I do interviews, sometimes I do them on both feet. About half of this interview has been on one foot or the other because I don't know, I like that. But if I were to close my eyes, I would crash into the microphone. So it wouldn't work out. I don't. So now, how do I improve my proprioception? Give me an exercise.
Let's do one of these cerebellar tests.
Okay.
All right. So what we want you to do, and so the listeners can hear it, is you're going to have your right hand out in front of you.
Gotcha.
All right. Your left hand, you're going to take the back of the hand, center on center, and clap it. And then you're going to move it to the other side, palm to palm. All right. Now go as fast as you can. And if it's not working properly, you start to hear a different rhythm. And so instead of that nice thud, thud, thud at a fast pace, so go as fast as you can. All right.
Try the other hand.
Put it close to the mic. So we're doing the left hand first, right?
Okay. So right hand's on bottom, left hand.
Yep.
Okay.
So clap it so people can hear it. Close to the mic.
Okay. So I'm spazzing out a little bit here.
Good. All right. Now compare the other side.
Okay. So now we'll do
as fast as you can go. And you should be able to hear it. I think we probably have some filters on our mic.
So the right one's a little more coordinated than the left one.
Perfect. So what's the weaker side?
Well, I assume
the left, right?
The left.
Okay.
Yes.
So now we want to stimulate that left cerebellum because we know that coordination of clapping side to side doesn't work as well. Now, balance,
I love this.
Yeah, balance is a push-pull.
Yeah.
Yeah, you fall to one side versus the other. It's a push-pull, right?
Okay. So
it's an easy. It's left versus right. So we know the left isn't working as well. So we want to stimulate the weaker side. So what we're going to do is we're going to stimulate the cerebellum by doing a novel movement task. So what I want you to do is I want you to make these sideways figure eights with your hand.
The left hand?
Yep. Make it nice and coordinated.
Okay.
Good. And you're only going to do about 10 of those. All right, now, if I wanted to do it a little more intensively, I would have you lie down and I'd only 10. You're only going to stimulate it a little bit. Okay. Fire out that part of the brain.
Okay.
Now, if I wanted to make it a little more intense, then what I'd have you do is I'd have you lie down and I'd have you do those figure eights opposite directions. So the foot is going the opposite way of the hand. So it's a brand new pattern.
Oh, I think my brain hurts already even thinking about that.
Exactly. Or what I'd have you do is with your hand, I want you to write the alphabet. And with your foot, I want you to write numbers.
At the same time?
Exactly.
Oh my God. People can do that?
No.
No.
It's new. It's novel.
Gotcha.
Yeah. We're only doing it to stimulate the brain. I could care
it's not a fail test. Okay.
Right. I could care less if you could do that. What I want to do is I want to stimulate that part of the cerebellum by doing something new and novel. All right. Now, what we do after that is we get you back on your foot.
Okay.
We have you close your eyes and we see, okay, is balance same, better, or worse?
I'm doing it right now. I know this is really boring for people listening to a podcast, but it's remarkably better. No, it's remarkably better.
Yeah. So that little stimulation through movement increases
oh my God,
your balance. So wouldn't you want to do that before skiing down a hill going 90 miles per hour?
Oh man. All right. So after we're off of this, you can send me some exercises to like keep me out of the hospital.
Yes.
That's so easy. Oh, I love this.
Yeah.
Gosh. Amazing. I might have mentioned to you earlier a long time ago. For some reason, I found myself studying Feldenkrais.
Okay.
So
Yes. Yeah.
Moshe Feldenkrais, similar, right? So tiny little movements, like weird movements, like shift your eyes right while you do this left with your foot, and it would just have this like tremendous increase on the vocabulary of movement you had in your body.
Absolutely. Yeah, and eye movements, they're huge because basically these tiny little cameras have so much information. So pointing these tiny little cameras are very important to the brain and nervous system. So different eye movements, different cranial nerves, they're going to tell me about different parts of that brain. And then excitingly, I can start to use that information like we just did with that clapping exercise to start to develop a strategy to hopefully fire into that part of the brain and make it better. And then if we see that improvement, then we need to practice it. And then once we become good at it, we need to change it up, reassess the system, and do something different.
This is fantastic. It's so, I don't know. I spent a lot of time like training my body in the gym and getting strong and fit and all this. And in like, what was that? Like 20 seconds, you changed my balance.
Right.
Amazing.
I can't wait. I can't wait for ski season now.
I'm going to hit you up with like a whole list of like exercises to like, for proprioception. But David, we're going to finish up. Is there anything you want to leave people with?
Absolutely. And that would be do novel tasks and really start to appreciate then the senses and sensations around you, because that's going to change your mood, how you feel, and how you think. And it doesn't have to be too complex. It just means trying something new, different, and stimulating our brains and getting ourselves into a whole new, better state. And I think that's the way to enrich our lives.
Sounds a good plan to me. This has been super interesting. I think we're going to have to get you back on. You have my brain super fired up right now thinking about all of this. I'm really glad that you took some time out today and to visit with us.
It's been a pleasure. I love geeking out about this, and more importantly, I love seeing and hearing people get better and improve how they're feeling and functioning.
If somebody wants to contact you, what would they do?
LinkedIn is a great avenue, and then through social media, The Hardy Brain on Facebook, Instagram, and then on my podcast as well, the hardybrain.ca/podcast, The Hardy Brain.
Gotcha. We'll put those links in the show notes.
Perfect. Appreciate it.
Thank you for joining us, and a big thanks to our sponsors, which makes this podcast possible. Go to insidetracker.com/ageist. Save 20% on all their products. Go to drinkelement.com/ageist. And Element is LMNT. And you can save on their products with a special deal that we have set up with Element. As always, you have the opportunity to leave up to a 5-star review wherever you're listening to this podcast. We would love that. And we would also love a comment wherever you're listening to this podcast. That really helps us out. If you want to contact me directly, David@superage.com. I answer all of my email directly and promptly. We got another good one coming up for you next week. Hope you're all enjoying the summer, and we'll see you then. Take care.